So when you are thinking about matching your graphs with equations, I always start with making a list of notes or facts that I know about the graph. So let's start off here with some notes slash facts that we may know. So number one, I see that this is a curved line. I see that it is curved up, so it slants up. If it is a curved line, that means that it cannot be linear. So that's one of the first notes that I make. I'm like, hey, warning sign, this can't be linear. And because I've memorized the way these graphs look, and also because we've really only talked about linear or exponential, we know that this one here would be exponential. All right, so if this is curving up, it's exponential. Let's see if we can find some other easy facts. I know that it is increasing. I know that the rate of change is the slope, and it is getting steeper and steeper. A couple things I also know here. The parent function for an exponential function goes like this. F of x equals a 1 plus r raised to the x. And we know a couple facts about this. This a is my y-intercept. And this r is my percent growth. Okay. So from this graph, I can find a couple things. I can actually find that my y-intercept is this spot right here. So my y-intercept is the number 4. So I could say y-int equals 4. And if I go from here, let's just pick some random points here. If I go from this point down here, if I go from 4 all the way up to, let's just say, this point, which is 1 over, hang on, let's see if I can change my pen. If I go to this point right here, this goes from 4 up to 12 up here. So this was 4 all the way up to 12. That means I increased by 3. It was multiplying by 3. That is a 200% increase. Okay, so that I would know that my increase here is 200%. In decimal form, it needs to be written in decimal form to actually fit in the equation. So my final equation right here would actually be, I can fill in all the things. I can say f of x equals 4, parentheses, 1 plus, and then I need my 200, but it's in decimal format, raised to the x. And if I wanted to simplify this, it could simply be f of x equals 4, 3 to the x. Okay? So that is the way that I would go about matching my exponential graph with an equation or just creating the equation. Let's try the same thing with a straight line. So a straight line here, I'm going to do the same exact notes slash facts. Let's start with the first one. It is a straight line. If it's a straight line, that means it must be linear. And we have a lot of things memorized about linear graphs. We know that a linear graph follows the f of x equals mx plus b, where my m is reported as my slope and the b is my y-intercept. All right, I'm going to change this graph to be red and continuous, just like my last one was. So I'm going to have it continuing off here and continuing down here. Try and get a little bit more red because we're going to annotate a few things, and I want us not to get lost. Now, one thing I need you to know about slope. Slope always equals rise over run. So if I want to use a different color here, I might do brown. I'd say rise over run. Okay, so to do that, I'd actually just pick 2 points on my graph. I'll pick this point and this point, and then I'm going to see how much I have to go up or down, and then I'm going to see how much I have to run left or right. Okay, so here obviously you can actually see that my rise is a negative distance, and I'm going to clear out a spot for me to write that right here. I'm going to say my rise equals negative 1, 2, 3, 4. So it's negative 4. And my run down here equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equals 10. And here my rise was 1, 2, 3, 4. Okay. So my run is 10, my rise is negative 4, so I'd say negative 4 over 10. In other words, to put this in decimal format as well, that would be negative 0.80 if I wanted to just add a bunch of decimals there. Now my y-intercept should be noticed for its spot right here. This is the y-intercept. Let me clear a spot for me to write that. Okay. This is my y-intercept right here. Y-intercept. And so we know that the y-intercept is going to be this value, which is negative 2.5. So we could say that is negative 2.5. Then we're just pretty much ready to go. A couple things, I can see that this slope is sloping down, and that would be decreasing. So it's sloping down, it is decreasing. But let's go ahead and write our equation out. We'd have f of x equals, and I'm going to take this slope, negative 4 over 10x, and then I'm going to have my y-intercept tacked on the end here, and that would be my nice equation. So, couple other things. This is linear. Something else I forgot to say, it's going down. Going down, which is the same thing as decreasing, which means that my slope is negative. And do we see a negative slope? Yes, we do. We actually see a negative slope. So that would be the way that I actually look at how to find the graph and equation buddies for different types of graphs. I hope that helps.